the same, that's a good sign. When you subtract factors, factorial numbers, the first step is to make the denominator the same, and now it's already the same. That's a good sign. So the denominator will just be the same, m1 plus m2. In the denominator, I'm going to combine m1r1 with m1r1 because they both have m1. So what I get here is m1 and multiplied by the r1 at later time minus the r1 right now. There's a minus sign here. There's a parenthesis because they are both multiplied by m1. And I need to add the same thing for m2. I can combine m2 and m2, r2 to r2, r2 with r2. So I get r2 at later time, subtracting the r2 right now, and multiplied by m2. Okay? Now, the definition of center of mass velocity is the difference between the position divided by delta t. So if I divide it by delta t, I need to have delta t in the denominator, delta t in the denominator, and that delta t goes into the denominator. So if you look at this term, that is the definition for the velocity of the first particle. And this is the definition for the velocity of the second particle. So indeed, the velocity of the center of mass will equal to computing the velocity of individual particle first and then add it up weighted by the mass. It works this way because the definition of velocity and position are just addition and subtraction. Addition and subtraction can swap their order, so you can pair terms together and get what you want. There is a similar proof for acceleration in the textbook, so I'm not going to do that. But you can see velocity is just, acceleration is just doing the same thing for velocity, so it will work out the same. And this sum of the acceleration of the particle weighted by the mass will be the acceleration of the center of mass defined by here. And we look at the acceleration of the center of mass because it's basically the acceleration of the microscopic object. If we know how the center of mass of an object is moving, we know how the system is going to move, and we can describe the motion of microscopic object. Okay? All right, let's take a break. Come back at 9:25.